Warning, the video you're about to watch contains mathematics at the level of college algebra and trigonometry. All material has an assumed prerequisite of both Algebra 1, which is elementary algebra, and Algebra 2, which is intermediate algebra. While some prerequisite topics are reviewed briefly, a more thorough review of these entrance topics can be found by searching the web.
It's the system of equations. We must deal with them all at once. Always looking for solutions. Positive outlook overcome.
Hello, my name is Roy Simpson, professor of mathematics at Cosumnes River College in Sacramento, California. This is yet another video in a series on plane curves and parametric equations. You should have already watched my videos at least on elimination of parameters for parametric equations and the concept and definition of a parametric equation. There is an optional video called the unique method for graphing curves, parametric curves by hand. However, that's for very complex curves, so not a lot of instructors are going to assign those, but if they do, that's how that video would be helpful in determining how to graph those. So in this video, we're going to take a kind of a slight detour and talk about specifically taking a linear equation that's Cartesian in form and finding out what the parametric equations for that Cartesian equation are. So if given a point x1 sub y1 and a slope, which is just a change in y over change in x, the parametric equations for the plane curve are x equals x sub 1 plus change in x times t, and y is equal to y sub 1 plus change in y times t. Again, remember that change in y is the numerator of the slope, and the change in x is the denominator of the slope. So that's all you really need to make the transition from a Cartesian form of a line to a parametric form of a line. Now, I originally was not going to do a proof of this, but this video is going to be so short that I thought, you know what, let's quickly do a proof of this. So let's assume that you've been handed a linear equation in Cartesian form. That is, you've been given the equation y minus y sub 1 is equal to slope, which is m, times x minus x sub 1. And remember that, well, one, you can add y sub 1 to both sides, but also that m is just a change in y over a change in x. There's no real need to call it m if you don't want to. You can just call it a change in y over change in x, or rise over run. Well, taking a look at this, you could actually manipulate this slightly. You could say y is equal to y1 plus delta y times 1 over delta x times x minus x sub 1. And then you could say, well, what if we allowed t to equal this whole back end statement? So let me just say that. Let t equal 1 over delta x times the quantity x minus x sub 1. Well, what does that mean now that we know what y is? So this would imply that y in parametric form is equal to y sub 1 plus delta y times t, which is what we wanted to get. But what does that mean about x? I would love it if x were x sub 1 plus delta x times t. Well, if that's the case, we make this substitution, then it is also the case that if you multiply both sides by delta x, you get delta x times t is equal to x minus x sub 1. Adding x sub 1 to both sides, you get the desired result, actually. And so these are your parametric equations. That's it. That's the proof. So all you really needed to do was take the equational line they handed you, trade out m for delta y over delta x, because that's what slope is, and just call that stuff that's attached to delta y, call that t. And then you pretty much have the derivation of an equation of a line. So let's go ahead and use that theorem to find the parametric equations for the line passing through these 2 points. By the way, either of these points will suffice for x sub 1 comma y sub 1. So I'm just going to choose this point right here as my x sub 1, y sub 1. Also, you're going to need a slope. but that shouldn't be too difficult to find, right? Slope is just going to be, oops, something just happened there. Slope is just going to be the difference in y values. Let me go ahead and write that down. The y values are 7 and -5, so 7 minus a -5, divided by the difference in x values, 6 minus 12. And that will be 12 over a -6 or a -2. Remember, the highlighted blue point there is my x sub 1, y sub 1. And according to the theorem, x will equal x sub 1 plus delta x times t, and y will equal y sub 1 plus delta y times t. If I said sub t, I meant times t. So let's see, x sub 1 is 6 plus, so there are a couple ways you could write this. You could say, remember, this is supposed to be delta y over delta x. So technically you could say that delta x is a -6 and delta y is 12. Or you could use this form and say that delta x is 1 and delta y is -2. It's your choice. I'm going to use the -2 over 1. So my delta x is just 1 times t. And then let's see, y sub 1 is, let's see, 7 plus delta y, but delta y in our case is going to be a -2 and then times t. So the parametric equations for that line are going to be x equals 6 plus t, comma, y is equal to 7 minus 2t. There you go. Completely done. Not much else you need to know about transitioning from Cartesian lines to parametric lines. It's just a sub-topic, and it's a little bit faster to do it in a single video. That's it for this video.
It's the system of equations. We must deal with them all at once. Always looking for solutions. Positive outlook overcomes obstacles getting in our way. Cause affects more than we can sometimes see. Things for what they are and work together until you feel at peace. Just listen close. Don't talk too much that isn't kosher. You may really hurt inside. It doesn't justify you to speak too loud and cry.